Hello, hi, good morning, my dear students. Welcome to the chemistry class. In the last class, we have discussed the thermodynamic. So, application of thermodynamic we are going to discuss today. So, in the previous, we have discussed the functional variables, means what are the path functions and the state functions, and how they are having the terms, and how the system work, means work done on the system, work done by the system. Based on this criteria, by using this diagram, we are going to discuss today about the applications of thermodynamics. So let's start here. The application of thermodynamics, here we are going to discuss two terms. One is work, another one is enthalpy. So next one is there actually, but it is deleted in the new portion. Therefore, we are going to discuss the two terms here. The first one is work, means how we are going to calculate the work done by the terms of thermodynamics. So let's start here. So before we move to the applications of work, means to calculate the work done in the thermodynamics. So before moving that one, let me explain the two important terms here: reversible and irreversible process. So what is reversible? Look here. So reversible is nothing but it is one of the very common word it is. But what you have to remember here is, so whenever we use the word reversible and irreversible, we have to think that the meaning of reversible and irreversible. The best example is, think that you are dying from helicopter. You are dying from helicopter. So think that helicopter is somewhere in the sky, it is flying. If you die with the jacket, with your protection of jacket, means you can easily land on the earth, isn't it? So if you are dying with the jacket and lying safely on the jacket, means to the earth, means you can again go to the helicopter to die once again, isn't it? The same thing here. If it is, the process is called as reversible. If you are dying without any jacket, without any health protections, then it is called as irreversible. Irreversible. So it means that, think that it is a balloon. It is a balloon. If the balloon is fluid, means it is containing air. So if I lose that gap of the balloon at this time, so that air will be reduces slowly. Air will be reduces slowly. So this is called as, this is a balloon. So when this balloon having the fully filled by air, if I open some of the space to move the air outside, then the size of the air will go on reducing, and finally all the air present in the balloon, means the balloon will be becomes nil, isn't it? So if I can able to fill the air by once again by filling that inside, isn't it? So this process is called as reversible. Reversible. The same thing, if I did that, think that it is a balloon. If I, to this balloon, if I put some of the pin, if I touched by one of the pin, so one pin inda nanu balloon touch madide chuchide antandre, avage enagutte overall balloon is going to be blast. So it means that blast agantandre again I can't able to refill that balloon by the air, isn't it? Why? Because it is having some leakage. So it means that if I release the air by this mouth, means I can refill that one. This is called as a reversible process. If I pin by using this pin, if I touch that one, means if it is blasted, means it is not able to refill that one. This is called as irreversible. Reversible and irreversible. Very simple. ನಾ ಹೇಳಕ್ ಹೋಗ್ತಿರೋದು ಏನು ಅಂತಂದ್ರೆ, ರಿವರ್ಸಿಬಲ್ ಅಂತಂದ್ರೆ ರಿಪೀಟ್ ಆಗಿ ಮಾಡಕ್ ಬಂದ್ರೆ ಅದು ರಿವರ್ಸಿಬಲ್, ಮಾಡಕ್ ಬರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಇರ್ರಿವರ್ಸಿಬಲ್. ಗೊತ್ತಾಗ್ತದೆ ನಾ ಹೇಳೋದೇನಂತಂದ್ರೆ, ಬಲೂನ್ ನಾವು ಊದಿದ್ದು ಮತ್ತೆ ಅದನ್ನ ನಾ ಇಲ್ಲಿಂದ ಬಿಟ್ರೆ ಏನ್ ಹೊರಗಡೆ ಹೋದ್ರೆ ಅದು ರಿವರ್ಸಿಬಲ್. ಆ ಊದಿದ ಬಲೂನ್ಗೆ ಪೆನ್ ತೋಡ್ ಚುಚ್ಚಿದೆ ಅಂದ್ರೆ ಅದು ಇರ್ರಿವರ್ಸಿಬಲ್. ಯಾಕಂದ್ರೆ ಮತ್ತೊಳಗೆ ಫಿಲ್ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ. ಇನ್ನೂ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೇಕು ಅಂತಂತಂದ್ರೆ, ನೀವು ಮೇಲ್ಗಡೆಯಿಂದ ಹಾರ್ತಿರ್ತೀರಿ, ಥಿಂಕ್ ದಟ್ ಒಂದು ಎಲ್ಲೋ ಒಂದು ಗುಡ್ಡಕ್ಕೆ ಹೋಗಿರ್ತೀರಿ, ಬೆಟ್ಟಕ್ಕೆ ಹೋಗಿರ್ತೀರಿ. ಬೆಟ್ಟದಿಂದ ನೀವು ಕೆಳಗೆ ಇಳಿಬೇಕು ಅಂತಂದ್ರೆ ಒಂದು ಥ್ರೆಡ್ ಅಥವಾ ಏನಾದರೂ ಒಂದು ಹಗ್ಗ ಹಿಡ್ಕೊಂಡು ಕೆಳಗಡೆ ಇಳಿದ್ರಿ ಅಂತಂದ್ರೆ ಮತ್ತೆ ಆ ಹಗ್ಗ ಹಿಡ್ಕೊಂಡು ನೀವು ಮೇಲ್ಗಡೆ ಬರ್ಬೋದು. ಆ ರೋಪ್ಸ್ ಹಿಡ್ಕೊಂಡು ಯು ಕ್ಯಾನ್ ಸ್ಟೆಪ್ ಇನ್ಸೈಡ್, ಅಬೋ ಬರ್ಬೋದು ನೀವು ಮೇಲ್ಗಡೆ. ಇನ್ ಕೇಸ್ ನೀವೇನೂ ಇಲ್ಲ ಅಂದರೆ ಡೈರೆಕ್ಟಾಗಿ ಹೋಗಿ ಬಿದ್ದರೆ ದಟ್ಸ್ ಕಾಲ್ಡ್ ಅ ಸುಸೈಡ್. So it means that ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬಿದ್ರಿ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಯು ಕಾಂಟ್ ಏಬಲ್ ಟು ರೀಕಮ್ ಅಗೇನ್ ಬಿಕಾಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೈ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಇರ್ರಿವರ್ಸಿಬಲ್ ಪ್ರೋಸೆಸ್. ನೀವು ಒಂದು ರೋಪ್ ಇಟ್ಕೊಂಡು ಕೆಳಗಡೆಯಿಂದ ಬಂದರೆ ಅಂದ್ರೆ ಬೆಟ್ಟದಿಂದ ಕೆಳಗಡೆ ಬಂದರೆ ಅಂತಂದ್ರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ರಿವರ್ಸಿಬಲ್ ಪ್ರೋಸೆಸ್. ಬಿಕಾಸ್ ಯು ಕ್ಯಾನ್ ಅಗೇನ್ ಗೆಟ್ ಅಪ್ ದ ಟ್ರಾಕ್, ಇಸಂಟ್ ಇಟ್? ಆ ಕಲ್ ಮೇಲ್ಗಡೆ ಮತ್ತೆ ಆ ಬಂಡೆ ಮೇಲೆ ಹತ್ತಿ ಹೋಗ್ಬೋದು ನೀವು. ಅದನ್ನ ರಿವರ್ಸಿಬಲ್, ಏನೂ ಇರಲಾರ್ದಂಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಜಿಗಿದು ಬಿಟ್ರೆ ಅದ್ರ ಮೇಲ್ಗಡೆಯಿಂದ, ಅದು ಇರ್ರಿವರ್ಸಿಬಲ್ ಪ್ರೋಸೆಸ್. ಸೊ ಹಿಯರ್ reversible means which can be repeatable, irreversible means which can be not repeatable. ಒಂದ್ಸಲ ಹಾಕಿದ್ರೆ ಮತ್ತೆ ಇನ್ನೊಂದ್ಸಲ ರಿಪಿಟೇಷನ್ ಆಗೋದಿಲ್ಲ, ಅದು ಸಡನ್ ಚೇಂಜಸ್ ಆಗಿಬಿಡುತ್ತೆ. ಸಡನ್ ಚೇಂಜಸ್. ಇಫ್ ಸಮಥಿಂಗ್ ಇಸ್ ಹ್ಯಾಪನ್ ರೆಗ್ಯುಲರ್ಲಿ ಆರ್ gradually happened means it is called as reversible. Suddenly happened means then it is called as irreversible. So keeping this 2 point reversible and irreversible, I would like to continue the main concepts here, that is application of work done. Why I am explaining this reversible and irreversible means here we are going to calculate the work done in reversible process and work done by irreversible process. So reversible is nothing but what happens here. In the reversible, the change in the pressure, external pressure will be changes gradually. It is changes variable. It is in the reversible, it is variable. Whereas in irreversibly, the pressure will be changes suddenly. Means suddenly is nothing but it is remains as a constant. So look here, application, that is in work. Think that it is a graph. Here this graph is showing that it is a pressure, external pressure, and this is about the volume. Think that initially the piston it is. Think that it is a machine which is filled by some of the gases in there here, and initially this is the piston. So if I applied some of the force to this piston, that is called as external pressure. If I applied some of the pressure from the outside, means it is called as external pressure. It means that I am doing the work on the system. If I am applying the pressure from outside, then it is called as I am working on the system. If piston moves outside means by the gaseous molecules present in this piston, it is pushing out the piston. So that is called as work is done by the system. Why I am stressing this one means if the work done on the system means the work done is positive. If work done by the system means work done is negative. Why? Because ಈಗ ನಾನೇ ಕೆಲಸ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ನನ್ನ ಎನರ್ಜಿ ಲೂಸ್ ಆಗುತ್ತೆ. ನನಗೆ ಯಾರಾದರೂ ಕೆಲಸ ಮಾಡಿ ಹೆಲ್ಪ್ ಮಾಡಿದ್ರೆ ನನ್ನ ಎನರ್ಜಿ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ, isn't it? So if work done by me, I am going to lose the energy. If somebody works on me on behalf of me, then I am going to gain the energy, isn't it? Same thing here also. Initially ಏನಾಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ the piston here, if some amount of pressure is applied by the piston, that is externally, that is called as external pressure. So think here, I am having this graph. This graph is going to represent the pressure versus volume. So here pressures remain same, means external pressure remains same here. And when some pressure is applied initially, means before applying the pressure, it is having the volume. It is having this volume. This is called as initial volume. Vi is nothing but initial volume. So I am going to call this as the V1. This as V1. And after applying the pressure by this piston is moving to some space. It is going to move inside. Therefore, it is going to occupy some of the space. Then see here, initially it is at Vi, means initially volume is up to here, is totally up to here. After applying some of the external pressure, then this is applied pressure. Here already I applied the pressure. After applying the pressure, the piston is moved to some extent inside. Then what happens? The volume is reduced from initial volume to the final volume. This is called as final volume. So I can call it this is V1 or this is V2. If I call this as an initial volume, then V2 is considered as a final volume. Can you see here the change in the volume? This is called as change in the volume. Because initially it is having from here to here, total volume up to here it was there. So when the piston is applied, the appearance of the volume is here V2 it is. Total volume is V2. Means initially greater volume, after V2 it is some reduced volume. Why? Because I applying the external pressure through the piston. So here what we have to do here, so here we are going to calculate the external applied pressure, that is called as external pressure, by using this condition. Means external pressure, what happens after this pressure? The volume is going to change. Volume change is initially it is having the volume V1 and finally it is having the volume V2. Means the difference between V1 and V2, that is called as difference of dV. Using this dV, if that dV can be also calculated by some of the another method, that is called as the length of this piston moved from Vi to the Vf, from initial volume to the final volume, how much the piston is moved, that is called as length. L is nothing but length of the length covered by the piston in the cylinder, and we can also calculate the area. What is the area of the piston? So by using this condition, by using this terms here, by this experiment we are having, so initially volume as Vi and final volume as Vf. So piston here, after applying the external pressure, the piston is moving inside, so that it is going to occupy some of the spaces, means spaces is reduced and volume is going to reduce here. So as the volume is reduced, we are going to observe that the volume is changed. So volume, how much it is changed, we can calculate that by the difference V2 minus V1. V2 minus V1 means initially and final volume. That the difference is called as dV. We can calculate that is dV. And also we can have the area, we can calculate by length, and this is the area. So by using this condition, by using this criteria, we can able to calculate the work done on the system. Work done on the system, what happens? So I said you, work done on the system means what we have to get? We have to get the work done on the system, means the work done should be positive. Why? Because in the last before class only, the last Monday only I have said you, so work done on the system means it is positive, work done by the system means it is negative. For that reason, do remember here, work done is on the system. For that reason, we have to calculate the work done as a positive. So to calculate this one, I am going to explain you some of the terms. Just look at these terms. Look here, to calculate the work done on the system, I am again and again telling you work done is on the system is positive. You have to remember this one. So here, to calculate the work done by this piston on the system, so let's first we will calculate, consider the volume changed in the cylinder. The volume changed in the cylinder can be calculated as, this is the distance covered by the piston, this is L and this is area. Length into area is going to give the change in the volume. This is the volume change. Initially it is V1 and it is finally V2. So I say to Vi is nothing but initial volume, Vf is nothing but final volume, and you can write that Vi as V1, Vf as V2. This is the distance or volume change. Therefore, this volume can be represented in the form of length and area. Length and area. For that reason, I have written here, volume change is equal to, that is the product of length into area. This is the length covered by the piston and this is the area occupied by the piston. For that reason, length into area, this is nothing but change in the volume. So change in the volume is nothing but it is Vf minus Vi, means V2 minus V1, both are same. That is the change in the volume, that is delta V. Delta V is nothing but change in volume. Therefore, change in the volume can be written as Vf minus Vi. If you need means directly you can write Vf minus Vi only. No problem with this. Look here, change in the volume I have written as a Vf minus Vi. It means that I have written as V2 minus V1. So whenever we take the V2 minus V1, this dV value means delta V, it's going to get the negative value. Why? Because can you see here, the total V1 is nothing but up to here this is V1, and V2 is nothing but from here to here it is called as V2. Can you see here, V1 is greater than the V2, isn't it? V1 is greater, but here V2 minus V1 we have written, means V1 is greater, means we are going to get the negative value of delta V. Delta V becomes negative. For that reason, here delta V is negative, but we are not supposed to get it is negative. Why? Because we need the main focus is work done. Here doing the work on the system means piston is working by external force on the system means work done should be positive. For that reason, what we are going to do here, delta V, change in the delta V means initiating volume and final value. The difference we are taking as Vf minus Vi, but you are not supposed to change V1 and minus V2. It's wrong. So final value minus initial value, this is the formula actually always. So by this formula we are going to get the delta V as a negative, delta V as a negative. But we can change this one later by adding one of the extra negative. Y means we will come to the next one. This is about the volume change. Next one is pressure. So next coming is the pressure. Can you see here the pressure applied here? The pressure applied on the system by the piston. So if we are applying the external pressure, this external pressure is nothing but it is going to say that the pressure is applying on the system means we are going to occupy some of the means we are applying some of the force on to cover some area for that reason pressure is nothing but it is a force applied on some of the area therefore pressure is equal to it is a force per unit area means one force applied on per unit area means here pressure is nothing but can you see here this is the pressure. Why we are applying means we are applying based on the force means force is applying. After applying that force it is going to occupy some of the area therefore force divided by area is going to give how much the pressure is applied by the piston. Therefore here if we want to calculate the force applied by the piston, force on the piston is equal to, so we will send this area to this side, this divided becomes into, therefore area into pressure is nothing but it is external pressure. Are you getting it what? So force on the piston F is equal to, after sending this area this side, it will become into area into external pressure. So to calculate the work done by the piston on the system, we will do the formula that is work done by the piston is equal to it is force into the pistons. So according to the physics we have studied it in the Newton's first law, second law, third law, the force, if we are applying some force on the system, means think that it is a duster. If I applied some force to the system, if it is moving means if it is changed its position means then only it is work done. If I applying the force means it is moving. If it is moving, if the position is changed means then only it is understood that work is done on the system. If that the position is not changed, if it is not changed in its position, if it is not covered some of the distance means it means that work is not done. This is according to the physics. Therefore here also what we are going to discuss is, so work done is nothing but it is a product of force into distance. So let's start here. Force is nothing but force on the piston is nothing but we know that it is the external pressure into area that is into distance covered is nothing but it is distance covered is L is the distance covered. So into L, keep in your mind. So now you can able to understand why I have taken change in volume as L into A. Why I have taken this formula means why, because I am going to use this L into A. And you see A into L is there. We know that L into A is nothing but it is a change in volume. Here I have not taken the change in volume. Here I have taken force into distance is nothing but work done. But I know that force is nothing but A into external pressure. But I have taken external pressure initially and A area here into distance is nothing but L. So A into L is nothing but change in volume. Therefore external pressure into A is nothing but delta V. So here I am going to take this delta V as a negative delta V. Why I am taking this one means I am not writing the negative for the change in volume. Why I am writing here? If to calculate the work done on the system means I need this work done always positive. Why? Because not always. Here we are applying the piston. This piston is working by the external pressure. We are working on the system. Means we are working on the the cylinder should carry the work as a positive, because work is not doing or done by the system. We are externally applying the work. For that reason, work done by the system always it is zero here. Means work done here on the system it is. For that reason, the work done is positive for the system. Therefore, why we have taken this negative means I already explained it here. Vf minus Vi, we are going to get the negative value, because this Vf is smaller, Vi is greater value. For that reason, we are going to get the negative. If negative term comes here means that W becomes also becomes negative, but we have to get it as a positive. For that reason, initially we are going to write this as a negative term. After negative of this delta V, minus into minus, it becomes as a plus. Are you getting my point? The negative term, why we have taken internally or inbuilt we have taken? Why? Because just precaution to say that W we need positive, because work is done on the system here. So delta V we are going to get a negative only. For that reason, negative, minus into minus, it becomes plus. For that reason, therefore, how much is the pressure applied? Here there is a change of volume, change in the volume. If we apply the integration to some duration, the volume by variation of this volume is applied here. For that reason, after applying the integration, so this formula becomes minus, we are taken as a negative constant, and integration of initial volume minus final value Vi, integration from Vi to Vf, or integration from V1 to V2, external pressure into delta V. So this is called as work done on the system here. Work done on the system. So here in this condition, so I said in the reversible and in the irreversible process. This expression W is equal to minus integration from Vy to Vf, external pressure into delta V. So this equation is called as, this is the equation for irreversible process. So irreversible change is nothing but here what I am explaining you is, so initially can you see here the piston is here. When we apply some of the pressure, after applying the pressure, the piston is moved here. But we are not applying the pressures from gradually we are not applying. We are applying the sudden pressure. So that pressure will form externally from this position to this position. Vi is moving directly to the Vf. Means distance covered is exactly L after applying the pressure. For this reason, the pressure is reversible is nothing but gradually changing. Irreversible is nothing but it is normally changing, means it is changing gradually, step by step it is changing. So here this is the work done on the system by the piston. Here the pressure applied is, suddenly we are applying the pressure. We are applying the pressure very suddenly, very fastly, not gradually we are applying the pressure. We are applying pressure very suddenly. This kind of changes is called as irreversible change. If the piston is applied gradually, then it is called as reversible pressure. If the pressure is applied suddenly and it can't be able to come again, if it is coming, again it is coming, means then it is called as irreversible process. So here, do remember here application of thermodynamics. So work done on the system at constant temperature, that is irreversible processes. This is the final expression. We have to write it. Okay. Look here, this seems to be a very small concept. Why? Because the work done on the system by this graph and two diagrams, and they explain this one is it takes very short time. But practicing by the understanding is the main thing here. Why? Because it will help you for applying or solving some of the competitive exams. If you move towards the NEET and JEE, means engineering and medical, you may have the very much difficulty to solve this kind of the problems. For that reason, do watch this video once again and practice it thoroughly by understanding. so that you can able to understand. Here this equation is for irreversible process, for irreversible change work done on the system, and next one it is we are having the work done by the system in reversible change. Then what happens means after condition pressure is variable, air pressure is constant here. So we will see that one more work done by the system at irreversible, means this is irreversible, that is in reversible in the next class. Okay, have a nice day, bye.